Hi, welcome back. Today we're going to talk about the f-distribution. The f-distribution is used to compare sample variances in two separate measurements, possibly of different populations. We have already seen the sample variance as a random variable as it appeared in the chi-squared random variable. That was for taking one measurement and comparing the sample variance to the population variance. But this time we're going to talk about two different samples and comparing their sample variance. All right, so let's start with the definition of the f-distribution, and this will be pretty straightforward. So the f-distribution describes the ratio of two independent chi-square variables. So suppose you have two independent chi-square variables, u and v, and suppose they have degrees of freedom nu1 and u2. So u and v are chi-square random variables, square variables, u with nu1 degrees of freedom, and v with nu2 degrees of freedom. Then the ratio, if I take u and divide by its degrees of freedom, divided by v divided by its degrees of freedom, is a random variable with an f-distribution. And there are many different f-distributions. It depends on the number of degrees of freedom in each case of nu1 and nu2. So we call this a random variable with nu1 and nu2 degrees of freedom. Okay. Sometimes you'll see it said it has nu1 degrees of freedom in the numerator and nu2 degrees of freedom in the denominator. The main application is that if we look at sample means, not sample means, sample variances. So if S1 squared and S2 squared are sample variances from normal populations, and independent samples, and suppose we know that the population variances are sigma 1 squared and sigma 2 squared respectively. Then what do we know? We know that that if you look at n1 minus 1, the number of degrees of freedom, the sample size minus 1, which is the number of degrees of freedom for my first chi-square variable corresponding to this quantity, s1 squared over sigma 1 squared times n minus 1. So that's a chi-square with n minus 1 degrees of freedom. And then I can divide that out by, I'll start writing this, but then I'm going to correct it a little bit. Divide this out by this, which is a chi-squared with n minus 2 degrees of freedom. So that's not exactly what I had up here. So how do you get an f-distribution? You have a chi-square variable with nu1 degrees of freedom. Then you divide out by its degrees of freedom. So I should actually divide out the top by the degrees of freedom, which is n minus 1, n1 minus 1, and then divide out the bottom by n2 minus 2. So this thing here was chi-square with n2 minus 1 degrees of freedom. And when you do this dividing out, what do you got? You got this thing as an f variable, a variable with an f distribution, with n1 minus 1 and n2 minus 2 degrees of freedom. But of course, notice that all these guys cancel. I have this in the, cancel letter A, so I have this in the numerator, and in the denominator, it's going to cancel there. these guys are going to cancel. So that tells me that if I look at S1 squared over sigma 1 squared divided by S2 squared over sigma 2 squared, then this is an F-distributed random variable as above with those degrees of freedom, right? And there's just inequality. All right. So let's now do some examples and see how this is used.